is pages 53 and 54 only. Only 53 and 54. Doesn't it make it sound like very little only when you say only? No. So in regards to transformations, we're pretty much done. So that some of you understand the type of brain that you have. There it goes. I was explaining it to the other class also. Really quick, on passing. There's 3 types of math brains. Okay? Some of you in here did really well in Algebra 1, and you actually, when you got the concept, you're like, oh, I get it. You have an algebraic brain. You do well with some of the algebra stuff. However, when you went to geometry, some of you struggled with geometry, even if you did well in Algebra 1. Why? Because geometry is a different type of math. That's what we call spatial math. Now, some of you that did really well in geometry, now we're back in Algebra 2. Some of you are like struggling with Algebra 2. Why? Because your brain is not algebraic. It's more spatial. Does that make sense for some of you? However, there's some of us that were blessed with having both brains. We can see it algebraically, or we can see it spatially. Now, in regards to teachers, here it goes. There's different types of math teachers. Some teachers like for you to show all the different algebraic work. Now let's think about the concept that we're just about to wrap up. It's about transforming functions. If you were to tell someone what is to transform a function, what would you tell them? What would you describe? If somebody gave you a graph and they asked you to transform it, what would you say? You have to do what? Monse, what would you? If I gave you a graph and I said transform it, what would you say? Change the location or the shape of it, but it remains pretty much about the same. Is that correct? All right, well, I'm that type of teacher. I like for you to understand the main concept. So, hopefully with these past lessons, we practice changing the location of a function and transforming the function into a different shape, but remaining pretty much the same, almost the same shape. Okay? Now, could I have given you a lot of the algebraic portion for you to do a bunch of computation for each table to do the entire function or transformation? Yeah, but that's a lot of computation. And that's where all of a sudden I start losing some of you in regards to doing both things. Doing the graph, which is spatial, and doing the work, which is algebraic. So I just wanted to focus on one. So hopefully we accomplished that. Okay? So, with that said, let's get started with our last lesson of the module. I can identify and graph an inverse of a function. I can identify and graph an inverse of a function. So here the concept we're still on. However, today we're not transforming, we're doing what? Identifying the inverse, and we're graphing the inverse. Write that on your Cornell note. We don't need a Freire model because we already know what functions are. Yeah, functions, we know that they're relations, and where there's one output for every input, and there's the examples, non-examples. Let me get my PowerPoint over here. All right. So, on your paper, write this down. Example Q. Identify the inverse of the function using a mapping diagram. You're like, uh-oh, this sounds familiar. Remember mapping diagrams that I gave you guys a quick demonstration of relations? You're like, kind of. Okay, here it goes. If I gave you a function, we need to have a what? A domain. And we need to have a range. Is that correct? And in order to be a function, there has to be one input for every output, or one output for every input. And we need to show the relation. That's why it's called what? Mapping. So here's the relation. That one to that one, that one to that one, that one to that one, and that one to that one. That's what mapping means. So copy that. All right, writing utensils down, look up to the screen. Here we go. So it says, identify the inverse of the function using the mapping diagram. So here's a function with a mapping diagram. So in order for me to write the inverse, the first thing I do is write inverse of function. You're not writing this down, you're just paying attention. You'll copy at the end. Here it goes. What does that mean, Mr. Q? Well, we need a domain and range, don't we? Domain and range. However, to write the inverse of this function, look what happens to the domain. Tell you never what happened. Yeah, the y values became the what? The x values. Let's see if it's true. So that means this now needs to have a 1-to-1. Is that correct? So what number goes here? Here, and copy that. Piece of cake, right? Let's go. All right, and then as you're copying that, I'm going to leave that on my screen over here, but I'm going to forward your screen for you to do one on your own. As soon as you're done copying, log your toolbar, and I want you to do the inverse of the function on the screen and press send. Copy and go. All right, let's see what we have here. Here goes the correct answer on your screen. Here goes another. Let's see. Here goes another. Do you agree with all those? Yes. Let me show you one that if you did this on a pop party, I would dock you a point. Tell your neighbor why, please. Let me show you another one. Once again, tell your neighbor why I would dock you a point. You're like, Mr. Q, only for the arrows? Well, what is that called? It's a mapping diagram. What makes it a mapping diagram? The arrows. And one last one that I would dock you a point. Tell your neighbor why. Because that's not a mapping diagram. That's a what? An input-output table. All right. So I think we got this, yes? Show me your parents how confused you are with that first example. Yeah, 5s or 10s or 10 to the second power. Yeah. All right. Let's crank it up a notch. Here in your graph paper, copy this one. If you need graph and paper, send Gopher. They're up here. Example Super Q says graph -4, 2, 0, -3, 1, 2, 4, 1. Then graph the inverse and copy the question. So for right now, just copy that, plot your original points, and then I'll do the rest with you once we continue. Copy that and go. All right. So let's see. It says the graph of the function, which is this. So let's graph that. I'm going to use, you use one color, I'm going to use blue. But if you already use your pencil or your pen a different color, that's fine. So I'm going to plot these. -4, -2. -4, -2. 0, -3. 1, 2. 4, 1. All right. We good up to right there? Yes? All right. But then it says graph the inverse. All right. So what I'm going to do before I graph it, I'm going to write inverse. And I'm going to write my point for the inverse. So think about it. Think about the previous example. But now I'm no longer using a mapping diagram. I'm using a set of points. What would be my first point? Tell your neighbor, please. That is correct. -2, -4. Tell them why -2, -4, please. Yeah, we're doing the inverse. We're just flipping the values, yes? So what would be my next point? -3, 0. And the next one, 2, 1. And the next one, 1, 4. You guys see my point? Get it? My point. Yeah. All right, let's plot these. -2, -4. -2, -4. -3, 0. 2, 1. And 1, 4. Now, for some of us that have spatial mathematics, all of a sudden now you start seeing something there. Some of you that don't see, you're like, I just see that I plotted new points, Mr. Q. All right. So let's show you something else to make sure you see what we need to see. They're asking us to look at it through the line y equals x. So what does that mean? I need to graph y equals x. So what is my y-intercept here where y equals x? Everyone? 0 plus 0. So I start here at the point of origin. I'm using black for this. What is my slope? 1 in fraction form is 1 over 1. That means I go from here, I go 1 up, 1 to the right, 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 1 up, 1 to the right. And remember, the more points you have, the straighter your line. Get your straight edge or your index card and graph your line. There it is. So now we have y equals x. So, look at that line that we just sketched. And now, I want you to start with the first point of our function, which is this one. And look at this line, and let's see if you notice what happens to this one. Let me go to the next point, this blue one. Here's this blue one. Look at the line and see what happens to that point in regards to its inverse. Look at this one. If we use this line, what happens to that? And what happens to that? Talk it over with your neighbor what's happening to the original function and its inverse. All right, so let's say I gave you an assignment tonight and I said, okay, guys, I want you to go home tonight and make it a family algebra 2 night. And you went home and you showed this to whomever's at home. But they don't remember any of this. What would you tell them on daily words, a daily application, that what does this line represent? Let's say you're with your little cousins that are in elementary. You can't give them algebra because they don't understand algebra yet. What would you tell them that the line represents? Tell your neighbor, please. What does it represent? Let's see. Allie. What does it represent? A mirror. That is correct. Let's see if it's true. Look up. Let's look at this line like a mirror. Here's my first point. If this is a mirror, then this will reflect this way. Let me show you the next one. Here it is. If this is a mirror, that means this one reflects that way. Do you see it? If that's true, if you say you see it, what if I plotted another point right here for my function? Plot the reflection of that one. Okay? Let's see. Here's my point, and if it's going to reflect, that means I go straight this way to this spot. And if you got that. Okay, good. Another word that we're going to use dealing with inverses and functions, instead of calling it a mirror, we're going to call it the line of symmetry. Who remembers that from algebra? Remember when we did the yeah. All right, show me your parents. I'll come to you with this second example. Yeah, we got this, yes? All right, I'm going to forward your screen. And I want you to do one by yourself. Let's see, like that one. There you go. Lock your toolbar. Do that on the screen. Okay. And for those of you watching the video, you can do that on your paper and practice that. Copy and go. Answer. Here goes the correct answer on your screen. Ready? Even though they didn't use different colors, but I'll take that. Here goes another. Oh. Okay. Let's see. Here goes another. Okay. We good? All right. So far, so good, yes? Let's crank it up 3 notches, yeah? Copy this one. Example, Michael Jordan cube. Let's go. And it reads, find the inverse function. Now we're going to say for it to be an inverse, it has the f of with a little -1 as the power there to indicate that it's the inverse of x. The original, we're just going to label it what? F of x. So this is the new notation for the inverse. It says, find the inverse of the function and use composition to verify that the functions are inverses. Then graph your functions and its inverse. So there's three things we need to do. Number one, find the inverse. Number two, verify. And number three, graph. Copy the whole thing. Yes, the instructions also. And then copy the function, and I'm going to show you the process. For this one, I do need you guys to be staying focused and pay attention and not take notes till the end, please. Let's see. Copy that. All right. Here we go. So it says, find the inverse of the function. So it's a long process, so I'm going to use different colors, so make sure you have your color pens ready and your pencil. However, once again, you're going to write the steps till the end. I'll tell you when to copy. Please don't worry about copying right now. I just want you to look at the process and understand it. Now, I'm going to label each step like always, so you guys can see each step, where you can actually write your process in words in your Cornell notes. Most of you know how to do that already. All right, here we go. I'm going to zoom in. Writing utensils down, look up to the screen. Here it goes. Here we go. Step one. Don't copy it, just tell your neighbor what step one is. You're like, that's it? Yes, substitute f of x for what? Y. Step two. Think about it. What would you call step two? Tell your neighbors, please. Isolate x or solve for x. Step three. Focus, please. Ready? Tell your neighbor what just happened. And tell them why we switched it. Because it's the inverse. Remember what we did with the points? Now we're doing it with the equation. So check this out. I'm going to rewrite this. Do you agree this is this? However, what was the original? F of x in function notation, right? Will I write f of x for this one? No, because it's the inverse. What do I write then? F of -1 of x equals x minus 4 over 3. Why? Because this is indicating that it's the inverse of f of x. Copy that, please. Bam! Let's go. Put this on a shirt. Cue merch. Bam! Copy that. All right. Any questions with identifying the inverse of a function up to right there? No. If you were to write these numerical numbers, Roman numerals in the front of your Cornell notes and you wrote explanation for each point, you should know how to do that, right? All right. However, we're only partly done. What did we just finish from the instructions that they gave us? It says, find the inverse. Did we find the inverse? Yes. Check this out. What's next? Use composition to what? verify. What's another word for verify? Wow, didn't I have you guys do a lot of that in algebra? Hello? That is correct. Check. Mr. Q, do we have to check? Yes. What are we going to check? Well, we're going to check the following. We're going to check, I'm going to start with f of x. However, I'm going to check that, let me make some space here, that if I start with f of x, but instead of substituting x into my original function, and I substitute the inverse in there, at the end, I should be able to get just a variable x, because that's what we solved for originally. That's it, Mr. Q? No. Of course we have to do it for the other. What is the other? F of the negative 1 of x. What does that mean, Mr. Q? Well, if I do f of negative 1, instead of substituting in there the x, what do I write in there? F of x, the original function. And what am I supposed to get with that, Mr. Q? You're supposed to get also what? X. So pretty much they cancel out and we're just left with a variable. All right. So at this point, writing utensils down, look up to the screen. There it goes. Because this is where it gets a little bit funky. What am I starting with, everyone? F of x. So I'm going to do f of parentheses. I don't write the x because I'm going to do something right now, but I just want you to see that I'm starting with f of x. So if I start with f of x, what was the original f of x? 3x plus 4. Do you agree with that? So here, I'm going to write 3 parentheses. What else? Plus 4. Is that correct? Let's see if it's true. 3x plus 4, but I just opened parentheses for the x's. However, instead of x, what do I have now in here? F of negative 1 of x. What is that, Mr. Q? The inverse. So what is the inverse function? What was the inverse? X minus 4 over 3. So here, instead of writing x, what do I write? X minus 4. You're just paying attention right now. Over 3. Are we there so far? Some of you are like, I'm confused, Mr. Q. Here it goes again. If I was to tell you to write f of x, what should it equal to? 3x plus 4, yes? So if I write it here, imagine there's an x here and x here. Isn't it 3x plus 4? Yes. But here we said instead of writing x, I'm going to write what? The inverse function. What was the inverse function? X minus 4. So here I write what I'm going to substitute. What did I substitute? X minus 4. So at that point, let's see. F of negative 1x, and you're just paying attention, equals to, well, let's see. What happens to these 3's? And we end up with what? X minus 4, what else? Plus 4. Okay. F of negative 1 of x equals, what happens to these 4's? So we're left with, did it check off? Yes. Copy that, please. Woo! So cool. And that's how we're going to do the other one. All right. So here goes the other one. F of negative 1 parentheses equals, what was my inverse function? X minus 4 over 3. So I write parentheses minus 4 over 3. As we start wrapping up, let me just finish this part. So, what do we substitute in here, everyone? F of x. Is that correct? F of x. So what was my original function? 3x plus 4. 3x plus 4. Therefore, f of negative 1 of f of x equals, what happens to the 3's? What happens to the 4's? And we're left with, and at the end you just drop it. Have a good one, guys. Enjoy your home play. It's only 2 pages. Once again, tutoring is free. Have a good one. See you guys tomorrow. Bye.